So this person, Brandon, wants to figure out in the school cafeteria if mushrooms should be added to the pizza. So the idea is you want a sampling method that will get the best results. Sampling method is the way you collect data. So here's our options. You can interview every vegetarian student, interview every student at a pizza parlor, interview every student who brings lunch home from school, interview every student who eats lunch in the cafeteria. Now I want you just to notice one thing, is that these are all different types of groups. And here's the basic idea for sampling methods. The idea is that instead of asking everybody, because we could ask everyone, or we could try. It gets more difficult the larger the group. But for sampling methods, we could ask everyone, but instead of asking everybody, we want to ask smaller groups that represent everybody. It's kind of like a small republic. So can you pick the smallest group possible that'll give you the most accurate answer? It'll never be 100% accurate, but there are ways to pick smaller groups that represent everybody in a somewhat accurate way. So keeping that in mind, A is out, because unless everyone is a vegetarian, picking a group of vegetarians won't be accurate, because why would vegetarians choose, for example, to have a meat pizza? Here, they would definitely maybe lean towards mushrooms because they're vegetarians. There's a bias here. So avoid biases. That's the goal. Avoid a bias that will, affect the result. Everyone has some kind of a bias, but this one in particular is a food bias, and this is a food survey, so it's a bad idea, a bad combination. Interview every student at a pizza parlor. This is also out because clearly people that are at a pizza parlor already have a strong food bias towards pizza. Interview every student who brings lunch from home. Well, again, people who bring lunch from home have a bias towards buying food. It's about buying food in the school cafeteria. So the only choice left is D, which is correct. If you can interview every student who eats lunch in the cafeteria, then you're going to get the best result of what the people in the cafeteria want. So that's the idea of a sampling method. And also, when you sample something, you probably have some kind of prediction attached to your sampling. And whenever you make a prediction, you sample, and then you have results from the sampling, and then you compare those results to your prediction. This is a loose interpretation of the scientific method. So here, this person's flipping a coin 100 times, and the amount of tails we have are 36 out of 100. And here we have a bunch of results that compare what happened. So in C and D, the coin landed heads more than tails. Well, here's the thing. If it landed on tails 36 times, we're also saying it did not land 37 or 38, but exactly 36. They're not saying at least 36 times. So that means the rest of the times it landed on heads. So the other 64 times it landed on heads. So the only correct choice here is that it landed on heads more than tails. And in these two cases right here, they don't really apply because we don't get a prediction from her. But sometimes you might get a prediction. For example, Joan predicts the coin will land on tails 25% of the time. So, and then I would say, well, the coin, in this case, if that was her prediction, the coin landed on tails more than she expected. And then you have to make a comparison between the prediction and the result. And that's the basic cycle right here.